section. I just saw you. It was so good to see you. Yay, yay, yay. Okay. You don't have to copy this question down because it's going to be part of your homework tonight when you look at it, all right? So in this question, what I want you to look at is the question and what is being optimized, okay? So the question here is, where on this curve here is the tangent line slope greatest, all right? So I think you'll agree that in this case, we're not optimizing y. We're optimizing the tangent line to y. So we're optimizing y prime, all right? Now, if you are optimizing y prime, think about this. Let's go back a step. Back in the day, which means yesterday, right? If you are if you are optimizing the function f, I think we would all agree that we have to at least work with f prime, right? The thing that we're optimizing requires us to at least work with the derivative at that thing. If we want to find the max value of y prime, and right, y prime is the slope of the line tangent, we're going to have to at least work with the derivative of y prime, which is y double. So on this second night of optimization, what you're seeing is just kind of more nuanced questions about what you're optimizing. In this question here, you are optimizing y prime. What that means for you is the following, okay? We're going to set up together. Why can't I just get rid of this? Dagnabbit. Oh, there we go, all right? So here's the thing. If you're optimizing y prime and you're given y, the first thing I have to find is y prime. I want to find the max of y prime. I first cleaned y prime, okay? Here's the thing, G section. There is nothing better, I should say this, there's nothing worse you can do in terms of calculus than not making yourself practice with the algebra. Not practice with judgments like this, right? That's y prime, here is me cleaning y prime. If I want to optimize y prime, I have to then find y double. And here is y double. So really, yes, this is y double, but this is also, would you agree, the first derivative of the thing that we're maximizing. Now we're going to sit right here together for a second. We're going to look at y double, and this is what we want to set equal to 0. And I want you to look at something. Look at this term and look at this term, and ask yourself what a common factor is, okay? I think you all see the -2, but also what's common is 1 plus x squared to the -3rd, not to the -2nd. And I bet some of you are like, wait, what, who, why, where? Okay, this makes perfect sense because look at this. When you had to factor back in the day, a cubed b plus a squared c. When you factored out the common factor, you said to yourself, well, the common factor here is a squared, because when I look at the two powers of a cubed and a squared, the lesser power is the common factor. You take the smaller exponent of the a. Right? What's smaller here? -3, or is it -2? -3 is the smaller exponent. I'm going to factor that out. And I'm going to challenge you, folks, algebraically, understand or explain why it is that this, when you factor 1 plus x squared to the -3rd out of this, why am I left with this? I want someone to have that explanation for me tomorrow. When I factor this out of the second term, I think you'll agree that I land here. At this point, I'm going to let you take it the rest of the way, okay? So once again, this question is a little bit more nuances. There's more nuanced here. You're maximizing not y, you're maximizing y prime. What I want to see is what you do with it the rest of the way when you take it all the way home, okay? Good job, and I will see you tomorrow. Goodbye.